Namaskar, I am Biju Dharmapalan and you are watching Science Time, a show that brings you the latest developments from the world of science and technology. Let's first look at some of the exciting stories. Scientists achieve a breakthrough in nuclear fusion. Indian telescope reveals the secret of mysterious circles in space. Bipedalism in humans may have come from foraging in treetops. Now let us see the news in detail. Researchers at the National Ignition Facility at the Lawrence Livermore National Laboratory in California achieved a breakthrough in nuclear fusion. For the first time, humans have harnessed the process that powers the stars to generate more energy from a fusion reaction that was used to start it, otherwise known as ignition. Nuclear fusion involves smashing together light elements such as hydrogen to form heavier elements, releasing a huge burst of energy in the process. The approach, which gives rise to heat and light of the sun and other stars, has been hailed as having huge potential as a sustainable low-carbon energy source. It is the opposite of nuclear fission, where heavy atoms are split apart. Fission is the technology currently used in nuclear power stations, but the process also produces much waste that continues to give out radiation for a long time. It can be dangerous and must be stored safely. Nuclear fusion produces far more energy and only small amounts of short-lived radioactive waste. And importantly, the process produces no greenhouse gas emissions and therefore does not contribute to climate change. But one of the challenges is that forcing and keeping the elements together in fusion requires very high temperatures and pressures. Until now, no experiment has produced more energy than the amount put it into to make it work. The amount of energy they have generated in this experiment is tiny, just enough to boil a few kettles, but what it represents is huge. The promise of fusion-powered future is one step closer, but there is still a long way to go before this becomes a reality. This experiment has cost billions of dollars. Fusion does not come cheap. But the promise of a source of clean energy will certainly be a big incentive for overcoming these challenges. Now let's move to the next story. An international team of researchers, including from India, has revealed that mysterious hazy circles of radio emission deep in celestial space could be remnants of supernovas, the biggest explosions in the universe. The emission circles, known as odd radio circles or ORCs, were detected recently using some of the most sensitive international radio telescopes. Astronomers used the Square Kilometre Array in Australia and South Africa, the Giant Meter Wave Radio Telescope in India, and the Low Frequency Array in the Netherlands to identify these radio emission circles, which are not seen in any other form of radiation. Researchers believe that some of these objects could be 1 million light years across, about 10 times larger than our Milky Way, and are considered mysterious, as these objects could not be explained by any previously known astrophysical phenomena. The discovery was led by Dr. Amitesh Omar, a scientist at Aryabhatta Research Institute of Observational Sciences, Nainital. His research indicates that these could be remnants of thermonuclear supernovas triggered by the explosion of a white dwarf star in a binary system heavier than 1.4 times the mass of the sun. Dr. Omar invoked a widely known mechanism of disruption of a star by extreme tidal forces exerted by a massive black hole as the star comes in close proximity to the central massive black hole in a galaxy. In this process, the star is destroyed and about half its mass is thrown away from the black hole at very high speeds. This disruption process releases a huge amount of energy similar to that produced in a supernova explosion. The sudden release of huge energy creates shocks which can traverse to around 1 million light years in intergalactic space. The research was published in the journal Royal Astronomical Society. Now let's move to the next story. According to researchers, the ancestors of humans may have begun moving on 2 legs to forage for food among the treetops in open habitats, contradicting the idea that the behavior arose as an adaptation to spending more time on the ground. The origins of bipedalism in hominins around 7 million years ago have long been thought to be linked to a shift in the environment when dense forests began to give way to more open woodland and grassland habitats. In such conditions, it has been argued our ancestors would have spent more time on the ground than in the trees and been able to move efficiently on 2 legs. But now researchers studying chimpanzees in Tanzania say that trait may have different origins. Writing in the journal Science Advances, the researchers report how they spent 15 months studying 13 chimpanzees living in Isa Valley in western Tanzania, an environment similar to that experienced by our ancient ancestors. The results revealed that these chimpanzees spent a greater proportion of their time on the ground and in movement when in an open environment of woodland and grasses than in densely forested parts of the same area. Now let's move to Science Quest segment. The question for this week's Science Quest is, what is echolocation? Echolocation is a technique used by bats, dolphins, and other animals to determine the location of objects using reflected sound. This allows the animals to move around in pitch darkness, navigating, hunting, identifying friends and enemies, and avoiding obstacles. Most of the world's 1,400 bat species use echolocation. They produce pulses of sound largely in the ultrasound range, which is high above the limits of human hearing. Most bats contract their larynx muscle to make the clicks via an open mouth, but some species use other body parts also. Leaf-nosed bats make calls through their elaborate noses, while some fruit bats make clicks by flapping their wings. As the bat closes in on its prey, the pulses increase in frequency to more than 160 clicks per second. The returning echoes then help the bat to determine the size, shape, texture, distance, and direction of the prey or object. At about 140 decibels, the shrieks are also incredibly loud. Just before it calls, the bat contracts its middle ear muscle, effectively dialing down its hearing so that mammal is not deafened by its cries. The situation is then reversed almost instantly so that the echoes can be detected. Echolocation is also used by whales, dolphins, a few birds like nocturnal oilbird, and some swiftlers, and some shrews and similar tenrec from Madagascar. With this, we come to the end of this edition of Science Time. Keep sending your feedback and suggestions through email. Our email ID is indiascience at vigyanprasad.gov.in. We will be back with more exciting stories from the world of science next week. Stay tuned to India Science.